In this video, I'm going to talk briefly about CPT theorem. CPT theorem. CPT stands for charge conjugation, parity, and time reversal. Actually, this theorem was first formulated by Julian Schwinger and later it was proved explicitly by Gerald Luders and Wolfgang Pauli. Sometimes this theorem was also called as Luders-Pauli theorem. According to this theorem, all interactions in nature are invariant under the combined operations of charge conjugation, inversion of the space coordinates at the origin, that is the parity P, and the time reversal. The orders of these three operations are immaterial. You can do any operation first followed by another one. So you can do it C first, then T, and then go for P, or do the P first, do the C second, and then T. So the orders of these operations are immaterial completely because there are three discrete symmetric operations. It also implies that if an interaction is not invariant under any one of the operations C, P, or T, its effect must be compensated by the combined effect of the other two operations. So far, all the evidence point to the validity of this theorem. No violation has been found yet. Now let's talk about charge conjugation. Charge conjugation is an operation in which all particles are transformed into their corresponding antiparticles. We know what are particles, and each particle have an antiparticle. Under this charge conjugation operation, all the particles are transformed into their respective antiparticles. Charge conjugation means reversal of the signs of all types of charges of the particle. Charges includes electric charges, baryonic charges, and leptonic charges. And this principle of charge conjugation is applicable not only to all the charged particles but also to the neutrally charged particles. We have many neutrally charged particles. One perfect example is neutrino. The neutrally charged neutrino has an antiparticle antineutrino. Both neutrino and antineutrino carry no charges, but these have different leptonic charges. Neutrino has a leptonic charge of +1 and the antineutrino has a leptonic charge of -1. So both has different leptonic charges and interact with other particles differently. And another very good example is positronium. Though it has a hydrogen-like structure, but it differs in nature. If psi represents a particle state, then psi star its antiparticle. Then C is the charge conjugation operator. When it operates on psi, it gives out psi star. So the above equation is true for psi star also. That is, C operating on psi star will yield psi. The electromagnetic and strong nuclear interactions are invariant under charge conjugation. The only weak interaction was found to violate the charge conjugation, which was inferred from the asymmetry in the beta decay of cobalt 60. Next, see what is parity. This operator, parity operator, is related to the invariance of physical laws under inversion of the space coordinates through origin, that is spatial inversion. This parity operator is equivalent to combined reflection and rotation. Here P is the parity operator which operates on psi of r comma t will yield zeta psi of minus r comma t, and here P stands for the parity operator. The parity operator has two eigenvalue. One is a plus 1, another one is minus 1. Here the plus 1 stands for even parity and minus 1 stands for odd parity. And the physical observables, that is psi, are the square of the wave function and are unchanged. And parity holds good for strong and electromagnetic interaction, and it is a known secret weak interactions violate the parity operation. The last one is time reversal. The operation t, changes the time t to minus t in all equations of motion of the system. That is the reflection of the time axis at the origin of the time coordinate. And this operator t is associated with the reversing all directions of motion including that of spin. The time reversal operation consists of the reversal of the signs of the momenta and the angular momenta. T also transforms the wave function to its complex conjugate. We know the Schrodinger's wave equation T operating on psi r comma t will give us psi of r comma minus t. So the known fundamental equations of motion are time reversal invariant.